Hi, welcome to my channel. My name is Clever. Today we want to talk about a very important topic in chemistry called balancing chemical equations. But for today, we want to talk about balancing complex chemical equations. But this method I'm going to discuss today, you can use it to balance both simple chemical equations and complex chemical equations. It's a very rare method, but I believe after this video, you won't have any problem balancing chemical equations, irrespective of the complexity. So let's dive in. So when it comes to balancing chemical equations, there is a popular method that is known by students, and that method is known as a trial and error method. But for today, we want to talk about a method called the simultaneous equation method. Now, the simultaneous equation method is a very rare method, but it is very useful and important to know this method while advancing or trying to learn chemistry, especially when it comes to balancing chemical equations. Why are we using the simultaneous equation method? Number one, it is very fast and reliable. Two, it is concise. Right? Three, it is straight to the point. So while using the simultaneous equation method, there's a goal, or there's a step-by-step process for you to arrive at a particular result. So let's take, for example, we want to balance a chemical equation that involves the combustion of methane. So methane, that's CH4 plus oxygen molecule, which will produce carbon dioxide and water. Now, for every chemical equation to be balanced, it means that the left-hand side must be equal to the right-hand side. And this happens for all chemical reactions, all chemical equations. They must be balanced, they must be equal. Right? So what goes in, and if you put in 50 grams of whatever amounts of reactants, the same amount must be produced, right? So that's just the whole purpose of balancing chemical equations, right? To understand if there is any loss in that particular reaction, right? So in this case, we are going to balance this chemical equation using this simultaneous equation method. Now, while using this method, the first thing that we usually do is to denote or represent the coefficients of each of the molecules, atoms, or elements present in that chemical equations by letter. So in this case, we're going to say let methane have a coefficient of A, oxygen B, carbon dioxide C, and water D. So we successfully denote the coefficient by letters, right? You can use any letter of your choice, right? Depending on how you understand the use of letters and symbols whatsoever. You can use symbols, and the most important thing is understand that what letters or symbols represent each of the elements or molecules present in your chemical equations. So in this case, since we've represented the coefficient of each of the molecules element here with letters, the next step that we want to do is to compare each of the elements on the right hand side to its corresponding element on the left hand side, or each of the elements on the left hand side with its corresponding element on the right hand side. So depending on what you're dealing with. So in this case, we have carbon, and carbon here is just 1. So 1 times A will give us A. So we have a carbon, so this A plus, that's this plus in this case. Now there's no carbon in oxygen molecule, so this gives us 0, equals to, in carbon dioxide we have 1 carbon also, so 1 times C gives us C, plus in water molecule there's no carbon, so this is 0. So in the case of carbon, right, we've been able to say that A is equals to C, so I'll call this equation 1. The next step is to compare the next element, which is hydrogen. Hydrogen here has 4, so 4 times A will give us 4A, plus there's no hydrogen in the next substance, so that gives us 0. So equals to, there's no hydrogen in CO2, so that gives us 0, plus but there's 2 hydrogen in water molecule, so that gives us 2 times D, which is 2D. So for hydrogen, we have 4A plus 0, which is 4A, equals to 0 plus 2D, which is 2D. I'll call this equation 2. So the next step is to take the last element, which is oxygen. So for oxygen, in methane, there's no oxygen, so that gives us 0, plus, there's oxygen here, that's oxygen molecule, so we have 2 oxygen, so 2 times B gives us 2B, equals to, there's 2 oxygen also in carbon dioxide, so 2 times C gives us 2C, plus, and there's 1 oxygen in water molecule, so 1 times D gives us D. So for oxygen, we have 0 plus 2B equals to 2C plus D, which will then give us 0, which will then give us 2B equals to 2C plus D. So I'll call this equation 3. Now, it therefore means that we have 3 equations present here. So the first equation, which is A equals to C, which is equation 1. The second equation is 4A equals to 2D, which is equation 2, while the last equation is 2B equals to 2C plus D, which is equation 3. Now, we now have 3 simultaneous equations. So what's the next step? Now, why using the simultaneous equation method, right? You can either now then use what we call the substitution method or the elimination method. For in this case, we're going to use the substitution method. And always note that anytime we are using the simultaneous equation method, A is always equals to 1. So in this case, if A is equals to 1, then from equation 1, we can say that if A is equal to 1, it therefore means that C is also equals to 1, because A is equals to C. Then from equation 2, since we have that 4A is equals to 2D, it therefore means that if I substitute the value of A, which is 1, into equation 2, I can get the value of D. So it means that 4 times 1 is equals to 2D. Therefore, we can say that 2D is equals to 4. Dividing both sides by 2, D can be equals to 2. Then, we can now say that from equation 3, we have that, from equation 3, we have that 2B is equals to 2C plus D, right? Now, we have the value of C, and we also have the value of D, but we don't have the value of B, which is the last value we're looking for. So it therefore means that if you substitute the value of C, which is 1, and the value of D, which is 2, we can get the value of B. So we can say that 2B is equals to 2 times 1 plus 2. So 2B will be equals to 2 plus 2. So 2B will be equals to 4. So dividing both sides by 2, B equals to 2. So in this case, we now have that A is equals to 1, B is equals to 2, C is equals to 1, and D is equals to 2. Now, we successfully obtained the values of A, B, C, and D. So all we just need to do is to then replace the coefficients that we denoted with letters in the chemical equations with the corresponding values. So in this case, we have CH4 plus oxygen molecule, which gives us CO2 plus water. And we have A as 1, so 1 times CH4 is CH4. We have B as 2, so put 2 for oxygen. Then we have CO2, that's C as 1, which is 1 times CO2, which is CO2. Then D as 2, so this gives us 2. So in this case, we can now see that the number of carbon here is 1. The number of carbon here is also 1. The number of hydrogen here is 4. The number of hydrogen here is also 4. 2 times 2, 4. The number of oxygen here is 4. And the number of oxygen here is also 4. 2 plus 2, which is 4. So we can now see that the left-hand side is now equal to the right-hand side. So in this case, this equation is now balanced. So we can see how the simultaneous equation method is very easy and straightforward to balance chemical equations. Subscribe to this channel for more videos like this, and let us know which topic might be interesting to you, so we can put it out there for more people to get insight and understanding on basic concept of chemistry.